How does a turbidity meter work? Have you ever wondered how scientists measure the clarity of water in the polar regions? One essential tool they use is a turbidity meter. This instrument helps researchers understand the quality of meltwater from glaciers and ice sheets. Let's break down how it works. A turbidity meter operates on a simple principle. It measures how much light is scattered by particles suspended in water. When light passes through a water sample, particles cause it to scatter. The more particles there are, the more light is scattered, leading to higher turbidity levels. To measure this, a turbidity meter shines a light source, often a light-emitting diode, through the water sample. A detector, like a photodiode, captures how much light is deflected at a right angle to the light source. This method is known as nephelometry. Some advanced meters also measure how much light is absorbed as it travels through the sample, which is called absorptometry. A typical turbidity meter includes three main components: a light source, a detector, and a sample chamber. The light source sends a beam through the water, while the detector measures the intensity of the scattered or transmitted light. The meter then converts this light signal into a turbidity reading, usually displayed in units like nephelometric turbidity units, formazine turbidity units, or formazine nephelometric units. For accurate measurements, turbidity meters need to be calibrated. This is often done using standardized suspensions like formazine, which mimic the light-scattering properties of natural particles. In polar research, where conditions can be extreme, regular calibration is vital to ensure reliable results. Some turbidity meters have advanced features that help conserve power, which is especially important for remote deployments in polar areas. In active mode, the sensor takes repeated measurements to average out variability. In sleep mode, it reduces power use but can quickly resume measurements when needed. In the polar regions, turbidity meters play a significant role in monitoring changes in meltwater streams and lakes. High turbidity levels can indicate increased sediment load from glacial retreat or permafrost thaw. By tracking these changes, scientists can assess the health of aquatic ecosystems and understand the impacts of climate change on polar hydrology. While turbidity is a useful indicator of suspended particles, it does not measure the color of water caused by dissolved substances. The relationship between turbidity and total suspended solids can vary by location, so site-specific calibration is necessary. In polar regions, factors like ice crystals or algal blooms can also affect readings, requiring careful interpretation of the data. Turbidity meters are essential tools for scientists studying meltwater and environmental change in polar regions. By measuring how light interacts with particles in water, these instruments provide critical data that helps track sediment dynamics and assess water quality.